So in part D, we're asked to use the best fit line to calculate the value of K. So as we said previously, the rate of heat transfer will be equal to K times the area times the change in temperature divided by the length. And so what we see here is that we have this on the y-axis, this on the x-axis. So this over here will be the slope because it's in the form y is equal to mx plus c, where c is 0. So the slope is equal to K times A over L. And so what we can do is we'll calculate the slope. For that, we can take 2 points on the graph. So we need to determine the change in y divided by the change in x. So we can, for example, take, it just matters that we pick 2 points that are on the line, not necessarily 2 points that we have plotted. Those don't necessarily have to be on the line. We have to choose 2 points that are physically on the line. Let's say maybe this one and maybe somewhere over here. So that will be, well, 80 for the for this first one, let's say, for delta Q, that's the y. Then for the second one, that's around 44. Then for the first one, it was 220 for the delta T and the minus 120. So this will give us a slope of around 0.36 joules per second Kelvin. And so what we will use now is simply rearrange this equation for K. So K will be the slope times L over A. So 0.36 times 0.01, which we were given at the start of the question, and the area we were also given. So this will give us 0.06 joules per second Kelvin meter.